Hello everyone, welcome back again. Greetings with your maths tutor, Mr. M, on X and Y channel. Here our idea is basically to try and solve mathematical questions to assist you in dealing with questions that are challenging, build a better foundation in grade 10 to take you further into your grade 11 and grade 12. This is pre-recorded. There will be live sessions, but besides that, if you have any questions whilst the session is pre-recorded, you can still share or drop a comment on the YouTube platform and we will respond to you. You can also share the link if you've come across this to your peers so that they can also have access to this channel for free. This is to help you build your foundation as we are in the COVID situation. Teaching and learning has become very difficult and limited access to teachers. So we try as much as possible to help learners wherever they may be. Without much, I will be dwelling on the second section of exponents and exponential equations. On the session 1, I dealt with exponents and the application of the exponential laws in solving and simplifying exponential expressions. So if you did not have chance to watch the session 1, I recommend you go watch section 1 because in your grade 10 examination, you will come across questions of that nature. And then it will also give you more ideas and understanding, taking it further into the exponential equations because it's one and the same topic. All right, so I wouldn't waste much of your time. We will get into exponential equations, which is session 2 for today. So we will deal with about 5 examples, and then later I'll share a follow-up activity or a homework that you can do at your own pace. So basically, when you're dealing with exponential equations, you have an exponent that is related to a number and with an equation sign. So in this case, it's an expression. There is an exponent here, equal sign, and a number related. Obviously, this question can be expanded in different form in many ways, but what you need to realize is there's an exponent, there's equal sign, and there is a number. Hence, we have exponential equation. So we will tackle the first example, which is the basic example that you may have dealing with exponential equations. So my example 1, will be x to the power 5 over 2 equals 32. So with this type of question, the question would ask you to solve for x. Because it's an equation, you are asked to come up with a final solution. So with this example, looking at your left side and your right hand side, on the left hand side you have a base with an index of 5 over 2. So the idea is to get rid of that index 5 over 2. How to do that? The mathematical approach is to reciprocate. You're going to use reciprocal of 5 over 2, which is going to be 2 over 5. So in applying this, you would come up with this. Flipping, you're taking the denominator up and you're bringing the numerator down, which becomes 2 over 5. You do the same on both sides, 2 over 5. As you can see, with 5 times 2 and 2 times 5, I'll end up having 10 over 10, and that can cancel out to give me x to the power of 1. And on the other side, this 32, which is a whole number, can be changed to an exponent that will help you cancel out whatever that is here. Or at this point, if the examiner doesn't say or does not restrict you with a calculator, you can easily punch this and get the answer out. But let's apply the exponential equation here by saying when you change 2 to the power 5, it gives you 32. And remember, you already have 2 over 5 as an index. Hence, this 5 can cancel this 5, and you end up having x now being equal to 2 to the power of 2, which implies that your x now is equal to 4 as your final answer. So key points to note. Your index is reciprocated. Mathematical term, you turn that fraction upside down on both sides, and then you change 32 also to an exponent that will help you cancel out this. And we can also change this exponent on our scientific calculator, the Casio. Easy to get the factors by using your second function. You press the number 32, you go to your second function, and then you look for this key FACT. Immediately you press FACT, it will bring you this information here, which is 2 to the power 5, or in the simplest breakdown, if you are not able to change it to that exponent by heart. You can use the calculator to guide you. So that is our example 1, which is one of the simplest one, and the skill here is to rotate to reciprocate the index on both sides of the equation and simplify further. All right, I'll go to example 2. I'll move to example 2. Which is x to the power 4 equals minus 6 to 5. X to the power 4 equals to minus 6 to 5. So this one also is the same approach. This 4 is divisible by 1. Change this whole number also to a number raised to the power of 4. That will help you cancel out this when you do the reciprocal application. Sorry about that. So here you have your x 4 or to the power 1 over 4 equals to, when I look at a prime number, 5. 5 can help me deal with this. So minus 5 to the power of 4 will give me my 6 to 5. And as I'm applying the reciprocal, I can do it on both. I have to do it on both sides. Why you're doing that is to help you eliminate or cancel out the reciprocated fraction. So with this, your 4 can cancel your 4. Now you're left with x alone. Then here 4 cancels 4 as well. and you're left with 1. So your x then remain as 5. That's your final answer. So that is example 2. Let's go further to example 3. So these are very easy ones where the exponents are just numbers to reciprocate and to simplify. Now, in going further, example 3, I'll just change the question slightly in this format. So here we have a question with the index being a number and a variable at the same time. So how do we deal with this type of a question? Let's try see what we can do. So if it is possible, we must be able to change this number to a base that will give us a solution. So here I would rearrange this, move this guy to the right, becomes negative, and look out for a base of 4 that will give you the 1024. And when I use 4 to the power of 5, I'll get this 1024. But at this point, what I realize is that my bases are not the same, because this guy here is what? Is a negative. And for that matter, I cannot equate the what? The index and solve for what? Solve for x. Had this negative be positive, then I will say since the bases are the same, then I can equate the index and solve for x. So in this question, what we have to realize is that due to this negative number, we don't have what? A solution. So we say no solution. No solution. All x does not exist. Alright, and you could have such type of question in examination. You just have to pay attention to how the question is what is given. Alright, now in going further to example 4, which is a very important example, and it's extended in grade 11 as well as grade what? Grade 12 is examinable. Previous section that we did apply that method called the K method. So we would have a question similar to that, but this time around we are going to solve the in an equation form, not simplify it in what? In an expression form. So here we're solving for x. In this question, we're solving for x, which is an exponential equation due to these guys here. But then don't forget the fact that one of the index is twice the other one. One of the index is twice the other one. So when it comes to such cases, we need to apply the K method. So my first approach is to reverse this with exponential law. Still the same, 2 times x will give you your 2x, and then move further and reverse this with the multiplication law. That is in section 1 we did the multiplication law, so you must remember this method. And now if you can see, I do have 6 to the power of x, 6 to the power of x repeated in the equation. So when you see such a repetition, then you'll come in with your K method that can help you factorize this equation easily. You can also factorize it direct if you don't find a challenge looking at the 6x as your 6 to the power x as your K. So with the K method, I'll say let K be equal to 6 to the power x. So in this equation, wherever I see 6 to the power x, I'll represent it with a k. So I'll have k squared plus k times 6 minus 7 equals 0. And try to solve for what? Solve for k in that regard. So rewrite this properly in your trinomial. We have your 6k minus 7 equals 0. And now that you've set the question in a standard form of a trinomial, which you would come across when you're dealing with equations and quadratic equations, you will come across what this is. So this square makes it a quadratic equation, meaning we would end up having two values of what? Of k, which in the end will help us solve for what? Solve for x. So how do you simplify this trinomial, or how do you factorize this trinomial? As I showed you in the previous section, look for the factors of 7 that if you multiply, it will give you negative 7, and if you add, it will give you positive 6. Negative 7 and positive 6. When you multiply, you will have your negative 7. When you add, it will give you negative 6. And you can see 7 is a prime number. So the only factors it has is 7 and 1. Hence, when I make 1 negative, 7 times negative 1 will give me negative 7. And 7 minus 1 will give me my 6, which is positive. Hence, I can put k here and say plus, and say k minus, everything equals to 0. So at this point, all we need to do is to apply the zero principle, by saying k plus 7 equals 0, or k minus 1 equals 0. Therefore, on this side, k will be equal to negative 7, or k equals to positive 1. But remember, the question asks us to solve for x, not to solve for what? For k. So how then do you get your x? Remember, you decided from the onset that you are representing 6 to the power of x with a k. So where we see k, we can bring in 6 to the power of x and solve for what? For x. So here I'll represent k with 6 to the power x, which will be equal to negative 7. But with this negative sign and this, there will be no what? No solution on this one. Then check this part. Wherever I see k, I'll put my 6 to the power x, and that will be equal to 1. The bases are not the same, but then I have 1 here. Is there any way you can change this or work this out? Remember one of the laws that says anything raised to the power 0 is equal to what? 1. All what you want to do is to get a base of what? 6, so that you can now equate the what? The index. So if a to the power 0 equals to 1, likewise 6 to the power 0 will be equal to 1. So in place of 1, I can now substitute 6 to the power 0. And therefore, my x value is equal to what? 0. Yeah, so that is the exponential equation that has to do with factorization. I hope you did grasp the most important process and the most important approach how to deal with this type of question with an exponential equation. And this is the type of a question you could have in grade 10, and it's an examination type question. I will write one similar question next to this one for you to give your hands on it as a try. see if you are able to apply the K method in solving this question. So this is your homework on this section. Only one question for you to try your hands on. 3 to the power 2x. So the question says solve for x. 3 to the power of x plus 6 times 3 to the power of x minus 27 equals to 0. Alright, returns. I hope you have enjoyed this section. This foundation that you are building is going to help you immensely. It's going to take you further into grade 11, and you won't have any problem getting into grade 12. If you enjoyed the session, subscribe as you're watching the video. Share the links also with your friends. Encourage them also to subscribe. It's a free tutoring. It's a free information that is being shared, and let's reach everybody that you know who is doing grade 10, 11 or 12, because there will be other sessions for grade 11, 10 and 12. Thanks for being here with us today.